Hello everyone, welcome to the video lecture series of Theory of Automata and Formal Languages. We are into unit number 1 and we are learning about finite automata. So in my previous video lectures, we have seen about finite automata with output, that is Mealy and Mealy Machine, and we have seen the construction of or designing of a Mealy machine and a Mealy machine. Now in this video I have brought two examples where we'll be looking into only the designing of a Mealy machine. If somebody have a little bit of confusion on designing of Mealy machine directly, in my previous video I was showing to construct a Mealy machine from a Mealy machine, and I will just narrate this particular scene where we will be looking only the construction of Mealy machine directly. Okay, it's very simple actually, but looking into the language, only if you are well equipped with construction of a DFA, then it is very easy to construct a Mealy machine or a Mealy machine. Just you need to focus on the output alphabets as well. Now what the language, look at the language right now. The language is given as construct a Mealy machine that takes the set of all strings over 0 and 1. So 0 and 1 has been taken as the input alphabets, okay, and counts the number of occurrences of the substring BA. Okay, so this is a small mistake over here because as we are having 0 1 as the input alphabet, so definitely it is 0 1 as the substring. Sorry, so here also we have to change. This is the content actually, 0 1 as the substring. Okay, so if I have 0 1 as the substring, it should count the number of 0 1 as the substring. That means how to count the number of 0 1? Definitely 0 1 should end into a particular state which you have to consider as an accepting state. That means I have to take A as the accepting state. Okay, that means if I see that we are having an occurrence of a substring as 0 1, definitely 1, the transition where it will end should have a output as A. A I have taken on my own. You can take any output alphabet as it is not mentioned over in the language. So I have taken A and B as the output alphabet. A generally denotes the output when the input string will occur substring as 0 1. Otherwise other states will have output as AB. But we will not consider with the states as we are talking about Mealy machine. We will talk about only with the transition. Okay, so let us start off with the restricted part. Restricted part is what? 0 1. So let me first draw the automata for 0 1. Okay, so I have taken 3 states. Initially this transition will give you 0 as a transition. Okay, and this transition will give you as 1 as the transition. Okay, it will give you 1 as the transition. I think this is clear. So 0 1 is the final answer. Okay, now apart from that, we can have we will first construct the automata and then we will look into the concept of Mealy machine. So 0 1 we have done. Now we are done with the restricted part. Okay, now we can have we will look into the states wise. Okay, as it has to follow the deterministic part. Look into X state. It is having only one transition for 0. What is the other transition for 1? I can definitely start off with 1. So 1 is having no restriction, correct? So I can directly write down this self loop for 1. Okay, this is for 1. Okay, now I'm done with state number X. Now moving to state number second state. Second state is having a transition for 1, but it is not having a transition for 0. So if I take a self loop over here 0, so there it won't affect because it will overcome as 0 1 only. Okay, so that means I can take a self loop over here, and this self loop will named as 0 transition. Okay, sorry, this will named as 0 transition. Okay, it is named as 0 transition. Okay, now I'm done with the Y state. Now I'm moving into Z state. Now if you look into the Z state, I am not having a single transition for the input 0 and 1. So what I can do for 0 transition, I can take a self loop from a loop from transition from Z to Y. Okay, and this particular transition will explain you what it will give you the input alphabet as so input as 0. So this transition will give you the input as 0. Okay, and if you talk about as 1, so I cannot take a self loop from here from Z to Y as 1. Why? Because if I take a 1 transition, then it will be 1 1, and as I'm thinking that this transition to make as a as the output, so I cannot take a transition from Z to Y. So what I can do, I can take a transition from Z to X, so it won't affect my language. Okay, it won't affect my language, so this will be named as 1. Okay, I'm done with the process, I'm done with the automata design. Okay, now we will move into the concept of Mealy Machine. Mealy Machine says that the output alphabet is associated with the transition. So look into the first X. 0 1 is the initial one, that means 0 1, where 1 will end, the output will be what? Output will be A. Okay, 0 1 output will be A. Otherwise all the transitions will be having the output as what? Output as B, correct? So now if you look into the other transitions, all will be B. Why? See, if a substring is only 1, so it will always produce the non-final output, that is your B. If it is 0 only, then definitely it will produce only B. If it is only 0, then definitely it will produce B. Only 0 1 will accept as A, that means on reaching the final transition as 1, final input as 1, so this only will follow up with A, otherwise all will follow up with B. See, 1 is having A as output. Now if we look into this scenario, I haven't given this 1 as A. Why? Because if I look into the scenario 0, suppose if I take this self loop 0 1 then 1, so 1 1 will never give as output as A. Only 0 1 substring will give you output as A. That means 0 followed by 1, and 1 should always have a transition which is having an output as A. So that's you have to keep in mind. It doesn't matter that for 1 we are keeping as A, no, nothing like that. We have to look into the string and we have to look into the format. Okay, and this is all about your Mealy Machine construction. So first what you can do for construction of Mealy Machine, you can either construct a Mealy Machine if you are comfortable with that, and then just simply replace the transitions with the outputs, and then or else this is also an easy way, that first draw the finite automata for DFA for that particular language, and then for every transition based on the language or the substring given to you, you have to maintain the output alphabet. Okay, so I think it is clear to everyone. This is just an example that I have brought for you. If you haven't understand how to directly construct a Mealy Machine, I think it will be clear to everyone. Okay, so I will also give one more example that will help you out more, like it will help you out. Okay, so this is a very simple question to you all, that we have to construct a Mealy Machine that produces 1's complement of any binary string. That means 1's complement is nothing but, if you take 0, then its complement will be 1. Then if it is the string is 1, then it will be complement as 0. It will be equivalent to 0. That means whatever I've written over here is 1 if you having, it will be converted to 0, and if it is 0, it will be replaced by 1. So this is 1's complement. So if you are having any binary string, say suppose say suppose if I having a string like 0 1 1 1 1, okay, then what will be the 1's complement? It will be 1 4 times 0. I think it is clear to everyone. So that means if you look into this Mealy Machine, it is very simple. It is almost a very simple machine which produces 1's complement of any binary string. That means I can take a single state, and I can take a self loop for 1, and I can take a self loop for 0. And for one self loop, I have to get the output as 0. If I have a 0 state transition, then the output will be 1. So I will explain to you with the diagram. Okay, so I got one single state as A. This is an initial state only, and I have taken 2 self loop. If it is 1, okay, therefore the output will be what? Let me redefine the output with a different color. The output will be represented by 0. So if it is 1, it is replaced by 0. If it is 0, it is replaced by 1. That means if it is 0, the input string is 0, it will be replaced by 1. So it is very simple question where we have taken any binary string. Suppose if you want to look into this string 0 4 times 1. So initial state 0, okay, and 4 times 1. So 0 will be immediately converted to 1, and 4 times 1, 4 times 1, and immediately converted to 4 times 0. So that means the output will be 1 4 times 0. So this is how the Mealy Machine works. Okay, you can first draw the finite deterministic finite automata for a particular diagram, and then you can take the outputs based on the language given to you. Okay, so I think it is everyone is clear to these both the examples that we have discussed. One we have discussed about ending with a substring, and this one we have discussed about one's complement. Same way you can try multiple number of questions. This is just a video that we have created to make you understand. Rest everything depends on you to take the questions, to work out with different questions, bring out with different examples, and then you will get the different type of solutions as well. Okay, hope it is everything is clear to you all. We will move into the next video where we will look into some conversions of Moodle to Mealy and Mealy to Moodle. So thank you for watching the video. Stay tuned and stay updated.